Welcome back for the lessons for lesson 3.5. We're going to introduce the concept of functions. Functions are another kind of formal way to write just an equation. And it explains the input versus the output. There is one particular characteristic of a function that we're going to share in just a moment. Let's first look at just an example here. So let's say we have a list of people and their birth months. So let's just say the birth month is 1, and the student is Sarah, because I was born in January, and then 1 in Kelly, and then she was also born in January, and then 2 in Michael, he was born in February, and then Abigail was 5 because she was born in May. So this would not be a function because January goes to Sarah and January also goes to Kelly. So a true function can only have one output for every input. Now we could switch it around and say student is my input and birth month is my output. But that is not a function. This is a function because Sarah only has one output, and that's the birth month of January. Kelly has only one output, and that's also the birth month of January. Michael has one output, and Abigail has one output. So this is a function. Another example. Let's say you were purchasing boxes of Kraft macaroni and cheese, and let's say each box is $1.15. So the total cost can be described as $1.15 times the number of boxes. So if you don't buy any boxes, you have zero cost. If you purchase one box, your cost is $1.15. If you purchase 2 boxes, it would be $1.15 times 2 or $2.30. And if you purchase 3 boxes, it would be $3.45. This is also a function because we can rest assured when we go into the store, if the price is $1.15 per box, one box we know will cost $1.15 because it is set up like a function. Now, functions have special notation. If we wrote this in function notation, we could write this as B of, we would write it as C of B is 115B. B is my input, the number of boxes, and C is my cost. That is the name of the function. We can look at what's called domain and range of a function, and domain and range tell us what are the allowed inputs into the function, and they go through the function rule, and then what are the possible outputs of the function. So a function by definition is a rule that pairs each element in one set called the domain with exactly one element from a second set called the range. So in the macaroni and cheese example, our domains or input would be 0, 1, 2, anything up to a positive infinity, and they would all be integer boxes because we can only purchase a whole box. And the range, the possible outputs of that would be 0, and then all the way up through $1.15, and we said $2.30, all the way up to a positive infinity as well. So domain are possible inputs, and then possible outputs for the range. Now, like I said, there's a formal way that we look at functions. A function is a set of ordered pairs in which no 2 different ordered pairs have the same first coordinate. The set of all first coordinates is called the domain of the function. So here, 1 on this output cannot go with more than 1 over here. Sarah cannot go, this input cannot go with more than 1 over here. Kelly cannot go with more than 1 over here. But this output could have, January could have 2 people that have a birthday in January. Okay. So a relation is a rule that pairs each element in one set called the domain with one or more elements from a second set called the range. Every function is a relation, but not every relation is a function. Think back to the birth month example. So this is a relation, how birth months relate to students, but this is a function because every student can only have 1 birth month. Now, there is a way to use a graph to decide if an equation is a function. So if a vertical line passes through the graph of a relation in more than one place, the relation cannot be a function. So let's look here at the first one. If we were to draw multiple vertical lines, they are only crossing our graph 1 time each. So it is a function. Again, the second one, absolute value functions, those are functions, absolute value equations. Linear equations are also functions. This graph down here is not a function because they pass through more than one point. Each x has 2 different outputs, so not a function. So let's look at this retail sales specialist. If I see this posting for a job that says $18 per hour for a retail sales specialist plus commission and incentives. Let's say we were hired by this company. If X is the number of hours you work per week and Y is your weekly gross pay, write the equation for Y. Be sure to include any restrictions on the variable that are given in the ad. We are going to have some incentives that we don't know the particulars about and some commission that we don't know the particulars about, but we do know for sure that they get paid $18 per hour. So for X hours, they are going to multiply times 18. So the gross pay Y is equal to 18X. Then if you worked 15 hours, you're going to multiply by 15. And if you work 20 hours, you'll multiply 18 by 20. And likewise, each of these hours, you're going to multiply by 18. And we can go to Desmos. To check this out. So if we can make a table and put in our values of X, 15, 20, 25, and 30. And then we can say that we want the rule. We can tell the rule up here to do X1. I'm going to type it as X1 times 18. So I just gave it the rule, and there are the gross pays. So for 15 hours, we would make $270. For 20 hours, we would make $360, $450, and $540. Part C says, construct a line graph in Desmos from the information in the table. So if we press this magnifying glass here, it will show the dots, but we want it to construct a line graph. So we're going to put it in equation form. So we're going to tell it Y equals 18X. Only use the X1 and Y1 if you're putting it in a table. We're putting it in an equation, so we're just only going to use X and Y. And then it gives us the line graph for that. Part D says the domain and range of the function, what are they? So what are the allowed inputs? So I can't work negative hours, so that means my domain would be 0 hours up to infinity, and that gets a rounded parenthesis. Now, there probably is a limit to how many hours you could work in a week, right? 168 hours, that's if you got no sleep, but technically, so. And the range would be the minimum. It's always the minimum on the left and the maximum on the right. The range, the minimum I could make would be $0 if I work 0 hours. And then again, I have unlimited for my maximum value that I can make. E says, what is the minimum amount you can earn in a week with this job? What is the maximum amount? And the minimum amount we could earn in a week would be $0. And the maximum is technically unlimited, but let's say we worked 40 hours. That is a usual work week. And 40 would be $720. Our last example for lesson 3.5 here, it says, the chart shows a comparison of power usage between incandescent and energy efficient light bulbs. Use the chart to state the domain and range of the function for an energy efficient light bulb. So that would be this one here. So it looks like my domain could equal at minimum 450 light output. And that's going to go up to, it looks like 2,600. We're using a bracket because it can equal those values. And the range starts, it goes 0, 40, and then in between would be a 20. But this is less, about halfway through there. So I would say maybe 10. And then it goes not quite, or just above the 40, or right at the 40. So we'll say about 42 on the watts. So the domain in this case would be the lumens, the light output, and the range is going to be the watts, how much energy it uses to do that. Catch me back for another lesson.